Welcome back, learners. So in our previous lecture, so we were discussing about the assign option, and in the assign option we have completed the joints, as well as we have completed joints successfully. Now before I move on to the frame, so let me explain about the shell. Okay, so as you know already that all the options that whatever we have used, we will not be using at a time based on the complexity of the project that we have taken. So let us learn the options in detail. So for this project what we have taken, since it is a simple residential building, so let us learn only the few options which is suitable for this. So according to that, when I say to the shell, you can see the first option is the slab section, right? So since you have defined the particular material required for the slab, the particular type of slab that you want, whether you want a normal slab or a waffled slab or a ribbed slab, and based on what is the thickness of the slab you needed, and also based on what type of the loading distribution you required in the slab, so whatever you have defined there, so here we are going to assign it. Okay, here we are going to assign it. So therefore when I click on this shell, and in that when I click on the slab section, you can see that this is the one that we have defined, that is slab of 6 inches. So when I give apply, so you will show the no selected objects were found to receive this assignment. That means I have not chosen. So since it is already defined, so therefore if you want, I can choose like this, I can choose the slab like this, and I can give apply. So when I click on that, so the corresponding slab will be assigned, the properties of that slab will be assigned to that particular members. Okay, so that is about the slab sections. Okay, assigning the slab. So in the same manner, in the shell along with the slab, even you have the deck section. So here nothing can be given for the deck section, because in the define option we have not defined the deck section. So if we have defined the deck section in the similar manner to the slab, so when I click on the deck section, so the deck section, it will ask you for which material that you have selected and for which one that you are supposed to assign the deck. Okay, so here since we have not defined any deck, so here we cannot able to assign any deck section. So the next is wall section. Similarly, if we have defined any wall, then the corresponding wall can be assigned here. After drawing there, the corresponding wall can be defined. So here also in this, whatever the walls is present, so we have converted that wall loading, okay, to the UDL, and we have applied on the beam. So therefore we have not taken the wall section, so we have not considered wall here. Otherwise, similar to the slab, even the wall sections, whatever we have defined, and after that whatever you have drawn, so for that it will be assigned. Okay, so similarly, even the next option is openings. You have seen that we can create the openings either in the slab as well as either in the opening. Almost I think that before this and one more, almost 2 previous lectures, I have explained how to create the openings in the wall and slab. So the corresponding openings can be defined first. Okay, so like that, for example, you have 3 to 4 different dimensions of the opening, and once the slab is drawn and assigned, so to corresponding slab, whichever the openings you require, or to the corresponding wall, whichever openings is required, you can apply those corresponding openings. Okay, so that is about assigning in the shell and in the openings. The next one that you can have is the stiffness modifier. So you may have the doubt that what is this stiffness modifier, right? See, as per this ETABS CSI reference manual, they have developed the software in such a way that whenever it comes to the frames as well as whenever it comes to the shells, frames in the sense you have the beam and column, and shells in the sense all your slabs and decks, all those members, when the structure is analyzed, the software will analyze in such a way that the stiffness of that member is going to be considered same throughout the member. Like for example, if I have an 1 meter beam, okay, if I have an 1 meter beam, so theoretically if I say the stiffness of that entire 1 meter beam has to remain uniform until and unless there will not be any change in the thickness, or we can say that there will not be any change in the dimensions of the member. Okay, until and unless if there is any changes in the dimension, the stiffness of the member will not change, it should not change. But that is theoretically, but when it comes to the practical difficulties, due to some reasons, okay, due to some reasons, what will happen is due to the various reasons, the stiffness of the members may go into vary. I cannot say it definitely it is going to vary, it may go into vary. Okay, the stiffness of the members may vary sometimes. So in such case, if you need the exact analysis, like if you are not going to define, definitely even the software will also analyze by taking the stiffness of the members throughout same. Okay, so it is going to same, it is going to remain same. But in case if you want to have the particular definitions of the stiffness, you can see that you can go to the shell assignment in that stiffness modifier. So if we go to the CSI reference manual, or when I come to that kind of project, I'll explain you that how we can have this F11 direction, F22 direction, F12 direction, and that is of the membrane, then bending 11 direction, 22 direction, 12 direction, then shear 13, 23 direction, mass, weight, everything in which direction it is going to vary, everything we can get it from the manual, and we can give those values. Okay, we can give those corresponding multipliers, that is factors, and if you apply, then it will be analyzed according to that. That is why we are going to use that in that assign, that is the shell and the corresponding stiffness modifier. Similarly, the next that option that you can have is thickness overrides. Okay, so thickness overrides also, you can see that when in the define option also we used to have, right here you can see that your wall thickness we have considered to be either you can consider any wall, or you can consider any slab, or even in the frames and beams. Okay, even in the frames and beams, we have taken the dimensions to be uniform throughout, but practically, so it may not be feasible. For example, in sometimes the thickness of the slab is going to vary from one side to another side. Okay, the thickness of the slab is going to vary from one side to another side. Okay, the thickness of the slab is going to vary from one side to another side. Similarly, you can see that the depth of the beam may also be considered tapering, that is having highest thickness of the at the support, and when it is going to have the free end, the depth may be reduced. That is what we call it as tapering beam. So that option is available when we are defining. Okay, we can make the thickness of the beam going to be varied, or even the thickness of the column going to be varied, as well as when it comes to the slab also, your thickness of the slab can be varied, right? So it will ask you whether you want to have the same stiffness at all the four corners of the slab, or you can able to vary at the two corners or three corners. So that option is there. So when you define that option, so you can choose which slab to be like that. By choosing that slab, you can give the corresponding thickness modifier. Okay, for that slab you can give the thickness as you know, as you required, that is varying thickness, that is also there. That is how you're supposed to use that option, that when you have this thickness overrides. So the next that you have is the insertion point. Okay, so this insertion point is also, it is an advanced option which is going to use, where you have a point after which the properties of that entire member may change. So you can choose that point and you can define. For example, you have a beam, okay, of 2 meter. So let us say that up to 1 meter you are giving one type of reinforcement as well as one type of material, and after 1 meter you can give another type of reinforcement and another type of material. So like that you can have an insertion point in the software, okay, and you can make sure that the entire property as well as the reinforcement is going to vary. Therefore the member will be analyzed in such a way that even the results also it is going to vary from that insertion point. Up to that insertion point you are going to get one results, and after that insertion point you are going to get the another results. That is what you are going to use that option, that what you call it as insertion point. And the next that you can have is about the diaphragms. Okay, so we have already the diaphragms whatever we have assigned, so that will be assigned to the slabs diaphragm. Okay, that will be assigned. The same manner it will be assigned to the shells. Okay, yes, so that is about the applying the diaphragm, right? So the next option is, you can see that there is an option called edge releases, right? You may have this doubt that edge release, what is this? Yes, definitely this is applicable when it comes to the design of the slabs. Okay, yes, see, when we go to the IS 2000, that is for your RCC design, and when you go to the design of the slabs, you can see that based on the different edge conditions, the coefficients that whatever you are going to consider is going to vary. Okay, you can see that there are different edge conditions available in the IS code, that is 2000 IS code for the RCC. Whether all the four edges are continuous, all the four edges are discontinuous, or combinations 3 continuous, 1 discontinuous, or 1 continuous, 3 discontinuous, like that various combinations are there which is available in the practical, and corresponding you are going to consider the coefficients along the longer direction and the shorter direction. So the same manner here you can do it. Okay, for example, if you want to define one particular slab as per that, so you can choose that which joint, which number to be released, that is shell adjustment, which edge you want to make it released. Okay, that means if you released means it will be taken as continuous, it will be taken that the edge is continuous. If you are restraining means it will be considered that the edge is discontinuous. So like that, whichever you want, by making the option release option, you can make that, like assign, you can see that the shell. So anyhow, that option also I will show in detail when we take up the next projects. Okay, you can see the edge releases. Okay, yes, so that is okay. You can see that how many number of edges you want to release, everything you can do. That is about releasing of the edges of the shell members. So the next that you can have is about the local axis. This is not much important. So the next is area springs. As I already told, when it comes to your soil structure interaction, again this is an advanced option that you are going to use. So when it comes to the soil structure interaction, so we have to define the below the foundation whatever the soil is there as a spring. So whether you can define it as a point spring or an line spring or an area spring. So if you are defining that, then that has to be considered. So that time we are supposed to use this option, that is area springs. Okay, yes. So next option that you can have is additional mass. I already told, when it comes to the earthquake analysis, so your additional mass has to be considered even on the frames also, not only on the beams and columns, even on the frames also additional mass has to be considered. So that additional mass whatever you consider, that will be applied on the slab along with your normal loads. Okay, so that one is about in that shell option that you have about an additional mass. And definitely the pier labels and spindle labels I already told, that is an advanced option. So when we use that, we will define and we will do it here. Okay, So the next one is you can have this wall hinge. Okay, yes. So you may have the doubt, what is this wall hinge? Listen, actually, to be frank, learners, whenever you have I think I have already explained that there is one type of analysis called as pushover analysis. Okay, so the pushover analysis is one of the type of the dynamic analysis that usually it is performed in order to understand the behavior of the structure, especially in the steel. Okay, so when the steel structures is subjected to the earthquake, or when it is subjected to the lateral loading, to some extent the behavior of the steel as well as the behavior of the reinforced concrete structure is completely different. So when it comes to the steel, so after a certain loading there will be a formation of the hinges. So whenever there is a formation of the hinges, it is an indication that, okay, it is an indication that the maximum load has been taken by the structure. So furthermore the load is not going to take. So that time you have to make sure that no extra load or there will not be any increment in the load. That is what we call it as the hinge formation. Okay, that is present only in the steel, not in the RCC. In the RCC the hinges will not be formed. So therefore where you have a steel structure, okay, so there even the walls whatever you build, so the walls will be considered as an hinges only. Okay, so for that also you are going to apply the hinges. For that also you are going to consider the hinges. So that time you are supposed to apply the wall hinges. So that time we are going to use this option wall hinge. Similarly, the reinforcement to the wall hinge is also of the same nature. And the next option that already we have told, floor auto mesh option, that is an advanced option. If you have defined that there, then definitely we are going to do the meshing, that also we will show. Then wall auto mesh option as well as auto edge constraint, everything these options will come into picture when you have the dynamic analysis. That time definitely in detail we will see. And the last option that you can see is the material overwrite. Okay, so material overwrite in the sense, see, when I take up any material, so because in the beginning of the software itself I have showed you that we will choose that as per IS standards everything is concerned. So you know, when I take definitely everyone must have gone for the stress strain curve of the mild steel bar as well as HYSD bar. So that is how the behavior of the material is. And when you do the analysis of using those material, definitely the analysis will be done as per that behavior only. If in case if you have any new material, because you know while defining the material itself I have told you that you have another option to define the new material. Okay, you have another option to define the new material. So when you do that, definitely you have to give all those details. Okay, you have to give all those details. So while doing that, right, since you have defined the new material properties or the new method, definitely you are supposed to override that here. That means you can see that it may have some different stress strain curve, so you have to define it. So then only that can be assigned, and when you assigned it only, then you have an option to the software will assign according to that. Okay, that is how it is for the material override in case if you are using any new material. Okay, so that is all about the options that you can have in the shell option. So in the next video let us learn about the frame, and maybe in 2-3 videos let us complete this assign and let us go to the analysis and design. Thank you, learners.